Hello, hi, my dear students. Today we can discuss forward biasing. We have already studied about PN junction diode, right? In that, forward biasing, a just brief description we have given in last class. In detail, we can study about forward biasing. Okay. So, first of all, what is meant by biasing means? Biasing means if we connect an external battery to the PN junction diode, that is called biasing. Okay, so you remember PN junction diode? We have studied like this: P-type and N-type semiconductors connected together, and here comes what? This was what? Depletion layer, right? And here plus charge ions will come, here negative will come. So here in p-type, the majority charge carriers are holes, right? And minority electrons are there. Whereas in n-type, we have electrons are the majority charge carriers and minority holes will be there. So this was our depletion layer, which will create a potential barrier which opposes the further movement of electrons from n-type to p-type, right? So here comes a electric field which is in direction from plus to minus, right? Electric field. Now we are going to do the biasing. Forward biasing means when p type is connected to positive terminal, p to positive terminal of the battery and n to the negative terminal of the battery. Such connection, which is known as a true connection, this is called what? This can be called as a true connection, where P is connected to plus terminal and N is connected to negative terminal. Okay. If it is like that, we will call it as forward biasing. Now, here electric field also will be in the direction plus to minus, like this direction, right? So look at the external electric field and the electric field which is created due to the potential difference inside due to the depletion layer. Both are opposite, right? It is going in this direction, it is coming to this direction. Both are opposite. So what happens if we take the net electric field? It will be reducing, right? If both are in equal direction, the net electric field will increase. But if both are in the opposite direction, the net electric field reduces. So in forward biasing, what is happening? The net electric field decreases. As net electric field decreases means the depletion layer width also decreases. Otherwise, we can say the potential barrier height will reduce. How? That is, if this is the potential barrier, like this it was earlier. When after connecting this forward biasing, the width of the the depletion layer reduces, right? Its width reduces. So as a result, height of this potential barrier also reduces, right? So you can quote as what happens when net electric field reduces due to the opposite direction of external and internal electric field. So what happens? The potential barrier decreases. Height of the potential barrier decreases. So if the depletion layer length decreases, now it is easy for the electrons from n type to move to p type, and electrons move means there will be current flowing, right? So due to this, what happens? Electron moves from where? From N to P. From N to P. So movement of electrons causes current, right? So there will produce a current which we will denote in milliampere, okay? It will be in milliamperes. The current produced due to this forward biasing. Okay, fine. So next, earlier we discussed about the block diagram of forward biasing. Now this is a circuit diagram. Okay, so here this is PN junction showing this is P and this is N, and this is a voltmeter connecting VF. F for forward biased voltage, okay, and a meter is connected which is a current IF, which is a forward biased current. And here rheostat is connected for variable resistance, and the P type is connected for with positive terminal, N type is connected with the negative terminal. Thus it is a forward biasing. It is in forward biasing, right? Okay, so how you will, if voltage given and current drawn, if we write plot like this in practical, right? That is, in this case, if voltage is 0, current also 0, right? If voltage is 1, again the current is 0. If voltage is 2, again current 0. Voltage 3, current 0. When voltage is 4, current 1. When voltage is 5, current 2. What does it mean? That is, there will be a potential difference inside the depletion layer, right? In that depletion layer there will be a potential difference, so the external battery connected should be more than that potential difference. If that potential voltage was 3 volt, it is an assumption, okay? So in order to flow the current, we should give the external battery more than this 3 voltage. So up to 3 the current will not be there. So if we exceed that potential difference more than 3, when it comes 4 they are started to having current. Then only the depletion layer reduces and the electrons will move to P type, right? There will be a movement of electrons and current started to flow. So if we plot the graph of this current and voltage, how you will get the graph? That is, here we are plotting in y-axis current and in x-axis voltage we are plotting. Initially 0 voltage, it is 0. When the voltage is increasing, current is same 0, right? When it comes in the 4 volt, the current slowly started increasing, right? Like this the graph will be for the forward biasing. That is, the voltage, it is known as the point it started increasing. That voltage has different names. You try to remember the names. It is also known as cut-in voltage, then threshold voltage, then knee voltage, like that. Different names it is known as this one. The voltage current started to flow. Okay, that is known as the cut-in voltage or knee voltage or threshold voltage. Fine. Now, this much things you can remember in forward biasing. The points are P will be connected to plus terminal, N will be connected to negative terminal. There will be different directions of electric field inside like this and outside like this. Due to this opposite direction, the net electric field decreases. As it decreases, the depletion layer also reduces, potential barrier height reduces. Now the electrons are easy to move towards the N type. When there will be a movement of electrons, current start flowing. Okay. So the next class we can discuss the reverse biasing, which is called a false connection. Okay. Till then.